Hello everyone, let's learn about midpoint circle drawing algorithm. Now let us try to understand the basic about midpoint circle drawing algorithm. As we can see, every circle will have a center. That center of a circle may not necessarily lie on the 0 and 0 of the x and y axis. Suppose we have an x and y axis here. We may have a circle here. Okay, so if we have a circle here, this particular center will have, on the x-axis it will be xc, on the y-axis will be yc. Alright, so for given radius r and screen center position xc, yc, calculate pixel position around a circle path centered at the coordinate origin 0, 0. So what we need to do is we will try to put this center on the initial x and y coordinate. That means your 0, 0 on the x and y coordinate. Okay, then move each calculated position xy to its proper screen position by adding xc to x and yc to y. Omche chu x and y axis a hian in circle kan lo draw down chuan hemi center hi hela initial state a hian kan pot thla photang, hela hian kan da thla photang chuan kan hret tur chu xc le yc hi kan hret anga ya. Hela hian kan draw fel photanga la hian chuan a hnuwa kan draw fel to hnuwa hian xc le yc kan pe chhawanga kan add le vekanga omna nga ya kan da chhawle mai don dinani. Along the circle section from x equal to 0 to x equal to y in the first quadrant, the gradient varies from 0 to 1. Now we have 8 segments of octants for a circle. Circle drawing a hian kan hret tur chu nei tu na pawan lo hmuta a. We may have a circle here. Okay, this is your xc and this is your yc. So the first thing that we do is we take the circle on the origin of the x and y plane, that is here 0, 0 kan zu da thla phot mai ni. Chuan we will divide the circle into 8 segments. Okay, this is your first segment, second segment, third, fourth, fifth, sixth, seventh, eighth. So for each and every segment you will have a modified formula. Okay, in the first segment we will take y and x, second segment we will take x comma y, third x comma minus y, fourth y comma minus x, and so on. Alright, this is how we will calculate, and we will simply have to modify it a little bit so that we can have a circle. Alright, and we will have to write a program separately for each of these segments. Before we move on, let us try to understand the function of a circle. We have f circle of x and y is equals to x square plus y square minus r square. So when f circle x comma y is greater than 0, that means xy lies outside the circle. If the function x of y is less than 0, that means x and y lies inside the circle. Okay, if it is equal to 0, that means it lies on the boundary of the circle. We will explain this as we move on. As you can see from here, this is your line of a circle, but we have to represent this line in pixel format. Okay, initially we are here, and the next pixel we can choose here is yk and yk minus 1. These are the two pixels we can choose. Okay, so accordingly, between this yk and yk minus 1 we have a midpoint. This is your midpoint. Suppose in this first example we will have to choose yk because this line is closer to yk pixel. Okay, and if you see this next diagram, figure 2, we have this initial pixel. The next pixel we have to choose is closer to yk minus 1. As you can see from here, it lies below the midpoint. Then we choose yk minus 1. Alright, so how do we make a decision whether we will choose yk or yk minus 1 is that we have a decision parameter pk. Okay, we will see how to solve this pk. When pk is less than 0, the value on the y-axis will not change. Yk plus 1 will be equals to yk. That means the next pixel we will choose is xk will be incremented by 1. This is your xk. Xk will be incremented by 1. But your yk will remain the same because you choose this. Okay, now let's see another example. When pk is greater than or equal to 0, that means this line is closer to the yk minus 1 pixel. That means the next pixel you are going to choose is yk minus 1. Okay, here we have yk. Now the next movement you are going to choose is you will go from here to here. That means yk minus 1. And similarly on the x-axis, xk will be incremented by xk plus 1. Alright. Now let us see this formula a little bit. We will not go deep into this formula. On the particular segments that we choose, x will always be incremented by 1. X on the x-axis will always be incremented by 1. So xk plus 1, it is permanent. Alright. But whether we will have a movement on the yk side is not clear. As we can see from here, xk is always increasing from this side, but yk might be the same or it may be decreased. So we do not know whether we will increase or decrease the yk. That is why we put half here. That means we are taking a midpoint, and from the midpoint, whether we have a negative value or the positive value, we will choose yk or yk minus 1. Okay, now we'll go directly to here. If pk is less than 0, this is the next decision parameter that we will be using to calculate the next decision parameter. And if pk is greater than or equal to 0, this is the formula that we will be using to calculate the next decision parameter. Now let us try to recap it again. We will say it once, many times if necessary, no problem. If pk is less than 0, as we can see here, this is the pixel that we are in right now. This is xk, yk. If pk is less than 0, we will choose t. Okay. If pk is greater than or equal to 0, we will choose this pixel. So whether we will have a blur on this pixel on t or s depends on the decision parameter pk. Okay. And when we choose either of these, the next decision parameter that we will be using is calculated using these two formulas, separate formulas. You will have to remember this formula. Alright. Initially, we have a point 0r. It means that 0 on the x-axis, r value on the y-axis. So when we try to find the decision parameter initially, we will have 1 r minus 1. This is the formula that we will be using, which is equals to 5 divided by 4 minus r, or approximately we can take 1 minus r. So try to remember this formula. Simply p0 is equals to 1 minus r. This is approximation. Now this is the midpoint circle algorithm. You will have to remember this midpoint circle algorithm step by step. Whatever I have explained before is written here clearly, step by step wise. Alright, so what we have to do is first we need a radius and the center of circle. We will take 0r initially, 0 on the x-axis, radius r on the y-axis. Initially we will find p0 is equal to 5 by 4 minus r, or approximately 1 minus r. And then we will start calculating pk, the next decision parameter. So we have 2 pk decision parameter, these two, and on point 4 we will determine symmetry points in the other 7 octants. So first we will try the first octant and then all these octants, 1 2 3 4 5 6 7 octants. Move each calculated pixel position x, y onto the circular path centered on xc, yc and plot the coordinate values. So whatever we have xc and yc, when we have calculated all these values, we will simply add them. Alright. And then we will repeat steps 3 through 5 until x is greater than or equal to y. Now let us try to solve one example. When we have a radius 10. Okay. So we have radius 10. As we can see, P0 is equals to 1 minus 10, or approximately, as we said, 1 minus r, which is equals to 1 minus 10 minus r. This is your initial decision parameter. Alright, now let us try to solve this problem. Initially we have x0, y0 and radius r. Alright, and then the value of initial value of decision parameter is 9. So the pixel value on the x and y axis is 1, 10. We have 2k plus 1, 2yk plus 1. We will calculate this. Now we will have to choose p is less than 0. We choose the first one. If p is greater than or equals to 0, we choose the below one. Alright. So here, initially we have p equals to minus 1. When k is equals to 1, p1, we will use this formula, that is minus 9 plus 2xk plus 1 is what? 2 plus 1, which is equals to minus 6. Okay. When p is less than or equals to 0, what do? X is incremented, y is same. That means x is incremented by 1 from 1 to 2, y remains the same. Okay. Now let's see p2. The previous p is minus 6 plus 2xk plus 1 is 4 plus 1, which is equals to minus 1. Alright. Now again it is minus, so x will be incremented, y will be the same. X-axis is incremented by 1, 2 to 3, and y is still the same. That is 10. Now let us see p3. p3 equals to minus 1, the previous decision parameter pk, plus 2xk plus 1 is 6 plus 1. We will get 6. Now it is positive. So what we do if it is positive, x is incremented, y is decremented by 1. Alright. So x is still incremented from 3 to 4. Y is decremented from 10 to 9. Now let us see p4. So when it is positive, we use the second formula, that is pk is 6 plus 2k plus 1 is 8 plus 1 minus 2yk plus 1 is 18. Alright. So when we calculate this, we will get minus 3. Now it is again negative. X will be incremented by 1. Y will remains the same. So 4 is incremented to 5. 9 remains the same. Now when we calculate all these things, this is the answer we will get. Pause this video and try to solve this by yourself. Now when we solve all the pixel movement from the previous to the next, we have all this pixel value. We have to simply plot it on the display graphics. So initially we have 0, 10. This is 0, 10. And then we have 1, 10. We have 2, 10. Here, 2, 10. This is 2, 10. This is 3, 10. This is 4, 9, 5, 9, 6, 8, 7, 7. Okay. So it will be calculated this way. And then the first segment is finished. If we want to program it, this is how we will program it. You may use C, C++, Java or whatever. This is the formula. You can simply plot it using this. Okay, so when you calculated out all the segments, this is your first segment, and then another segment here, another segment here, another segment here. So this is another segment, another segment, another segment. It goes like this. We have completed only the first segment. Okay, So all the segment has to be calculated separately. Thank you.